Today, as we move down page 3 of the notes here to the bottom, we are going to spend today dealing with some applications that have to do with the slope we've been dealing with the last 2 days. So, first we talked about looking at a graph, finding slope. Yesterday, we looked at, hey, if I have a couple of points, I have this formula, I can find the slope. Today, you're going to get to see how you can use either of those to get some information based on what our problem happens to be. So, in our first one here, Mrs. Mock went on a trip and drove 300 miles in 5 hours. What was her unit rate? Ooh, we're going back to unit 1. Unit rate in miles per hour. Okay. So, yep, yes it is. So, here's the first thing that we need to do. Unit rate is going to end up being, I'll say this on video if I have to, even if you have to, turn sideways. Talking is not going to help you. 300 miles in 5 hours. So it's as simple as making that a fraction and doing a little division in here. So 300 divided by 5 is 60. So we're going to be doing 60 miles per hour. I need that in order to be able to make my table, my chart. Because all I'm going to do basically here now is say, okay, so if I can go 60 miles every 1 hour, our time is our hours in this case. So basically, I'm just going to do, for my distance, I'm going to do 60 times whatever time it is. Whatever my rate is, times time. So 60 times 0, I think we can handle that one. 60 times 1 is in 60 times 2. 60 times 3. And we're just going to keep, you can keep adding 60 if you wanted to do that as well. That would absolutely work for this. Until we've got our chart filled. So could I find a slope or a unit rate using that chart? I sure could. I could use any pair of numbers in there that I wanted to, and I would get back to that unit rate. But what we also want to do is see if we can take those, reminding ourselves that when we make a chart, those are really just coordinate points that we put into a chart form. So when we're going to plot, this is like my x-axis, my time is, and my distance is like my y-value, x and y, just like we do when we're plotting points. So 0 would start us in the corner. So we'd start at 0, 0, and we put a dot. Then we'd go to where our t value is 1. We'd go up to 60. Put a dot. 2, up to 120, put a dot. And we're just going to keep following our time value on the x-axis, and then up to the y. You kind of see a pattern develop here, which is what our slope is. I plot my points. But here's the part that I'm hoping is going to make a connection for you and make it where you can see how these things actually can go together. Okay, find the slope from the graph. Okay, so we said yesterday, I can use any 2 points that are going through intersections. Well, every single point that I have on here is going through one of those crisscrosses. Okay, so let's just say, I don't know, we'll just pick a couple here. Let's say we use these two. And so what I'm going to do here is remember when we're doing slope on a graph, we're doing rise over run, which means we're going to do our up and down part first. So I went up, but this isn't just one. I know it's only one block, but I went from 60 to 120. So I went up 60. So my rise is 60. My run is my left and right. So my run to get over to the second dot, I went over 1. There's my rise, there's my run. But here's the part that I want to add in where we make the final connection of things. The 60 represents my distance. It represents miles. And my run, represents time, which is in hours. And I swear I've seen that somewhere before. The slope represents my unit rate, the thing I did way back in step number 1 before I had a chart, before I had a graph or anything. I already had what my slope, in air quotes, was. So they're the same thing. So whether I have a chart, whether I have just some information there, I can get the unit rate either way. It's not going to make any difference, okay? But I could have done it with the chart and a formula. I could have done it here. I could have done it there. We got 3 ways we can do it. So, with that in mind, let's see if we only have pieces, if we can still find our rate of change. Again, rate of change is just a fancy way of saying find the slope with labels. Okay? We're not just going to put like 3 over 1 or 6 over 1. We're actually going to put words with it. But the words are going to be right on the graph. So, just like we did before, when we're looking at our graph, we've got to find places, see, not going through the crisscross, not going through the intersections, so that doesn't do us any good. Okay, this one does. That's going right through the intersection. That would work for us. Oh, where's another one? Okay, here. Again, got to be going right through the middle of the intersection. If they're not, we can't use them. So at this point, let me tell you, there's 2 ways you could do this. You can either say, okay, I'm going to use the graph. I have a graph here. So I'd look and I'd be like, all right, rise over run. Hardy's going to stick with this. So I start from my 1 dot and I go up until I get even with that second dot. So I went up, let's see, I went up from 90 to 180. If I wasn't sure how far that is, I can do it that way. 180 minus 90 is 90. So I went up 90. And then my run, once I'm here to get over to my dot, I went over from 2 to 4, which would be 2. So we've got 90 dollars, okay, so my up and down is cost, the money's right there, and my run is 2 to the right, 2 tickets. But here's the thing. I'm not done yet, because reminder, whenever you do rate of change, okay, I'm going to put one more little note up here. Whenever we do rate of change, the denominator, the bottom number, okay, the number on the bottom, always is going to equal 1. If it doesn't, we're going to go to the calculator. We're going to type in what we got there. And when I get this 45, what that means is that it's $45 per one ticket. That's my rate of change that I'm working with as I've got things. And reset. So that's a graphical way of being able to do it. I could have done that, and I'll describe that in a minute. I could have done that like I did here. I'm going to do it with the chart, but we'll get to that. So now I get to this chart, you're like, whoa, there's a lot of stuff going on in here. Here's what I'm going to do. I can pick, these are like my X values. These are like my Y's. So what I'm going to do is I'm going to go ahead. I can pick any 2 points in here I want to find my rate of change. I'm just going to use the first 2. So I'm going to rewrite these. So I've got the point 214, and I've got the point 321. And just like we were doing yesterday, I'm going to label my points. My first part of each one is X, so X1 and X2. And I'm going to label my Y's as well. Because even though I've got this back on my last page, I'm going to put it here too for convenience. When we calculate, when we have points, the formula is y2 minus y1 on top. Got to be on top. x2 minus x1 on the bottom. And as long as I have these labeled and I plug them into the same spots, it's really hard to mess this up. So I get here, and I go, okay, y2 minus y1 over x2 minus x1. The one suggestion I'll make is that if you're going to go to your calculator and not just do this in your head, that you do each part individually. So in other words, 21 minus 14, get my answer. 3 minus 2, get my answer. But then I've got to remember this is a rate of change. So I've got to put my Y, my dollars, Y's on top. Why I put number down here, I don't know. That's kind of interesting. I guess we're going to leave that at $7 over 1 because I forgot to change the label in there to something else besides a number. So that would work that way. Any pair, you can make x1, x2, y1, y2 and get there with that. Okay, one last one on here, and then I'll get you a little bit of start on the practice, and we'll be okay. Oh dear. A red slide has a drop of 5 feet and a run of 2 feet. Okay, so let's do a little labeling here. A drop. So if you think about a drop, you're going down. So my rise would be -5. And my run of 2 feet didn't talk about anything bad. So my run would be +2 on that one. And the blue slide has a drop of 8 feet. So it went down 8 feet. My rise, my up and down would be -8. And a run of 3 feet, which would be positive. It didn't say anything about left or anything like that. Okay, which slide is steeper? Well, let's see. So we've got -5/2 versus -8/3. Ooh. You're like, okay, well, how am I supposed to tell which one's steeper? So let's get a little assistance here. If I do -5 divided by 2 on my calculator, okay, I get -2.5. Now, again, you're like, Hardy, I thought you said no decimals. I did, and we're not going to use decimals. I'm just using this for a reference. So -2.5. If I do -8 divided by 3, I get -2.66. So when we're going harder, which one is steeper? Okay, steeper just means it's a larger slope. It's a larger rate of change. That's more than that. 2.66 is more than 2.5. Now again, not literally. So for somebody looking at this later, Hardy, that negative is not bigger than that negative. I get that. But for our purposes of steepness, that's going to be greater. Because again, I'm going down more for my run than I am for those. So that's what I've got to watch out for when I'm doing some of those. Okay? So just something to ponder. So now, when we head to the application part here over on the worksheet, just got to write myself one note here quick. There we go. So over here, we're going to be doing the practice over on 9 and 10. Okay? This is where we go back to using our help here, our notes and things like that to help us out. So for instance, find the rate of change for each graph. Use labels. These are all like example 2 in the notes. Okay, we had our rate of change. We reduced it down to over 1. Made it work. If it's a chart, like the second one is, okay, that's like what we did here in example 3. Yeah, this chart goes with number 2. Yep. And so just like that, I can pick any 2 that I want, reminding myself that these are all coordinate points, and it's just x and y. So I'm going to use my slope formula. I'm going to use 2 of those points, and I'm going to give that a try. So example 2, example 3, we've got the first 2. We know what's coming, right? Or at least normally we do. Oops, and I forgot on this. Before I get too far, I got to come back down for a second. I forgot today the practice goes over to a 3rd page. So we're on 9 through 11. Yeah, I got a problem that didn't fit. So I come over here to the back. I come over here to page 10. And I'm like, okay, what am I supposed to do here? The exact same thing I did in the first example. Like literally. The same thing that we did in example 1. Now, I will say this. Okay, here is my unit rate. So basically what I'm going to be doing is I'm going to be doing whatever the time is times $7 because I'm making $7 an hour. And I'm filling in my chart just like we did in, whoop, I went to the wrong page for a minute. Sorry about that. To my first example. What's that? Yeah, once you get your points plotted here, again, all of these points are going to represent coordinate points that I can make on the graph. Now, you may sit there and say, well, wait a minute. Like, there's nothing on the edges. How do I know what's going on here? And I'll put it this way. If this is x and this is y, okay, my x-axis is going to represent time. And I just put, I mean, you can space it out more. You can do 0, 1, 2, 3, 4. You can spread it way out if you wanted to. And then my y-axis is going to be my money made in dollars. And once I have these values, once I do 0 times 7, 1 times 7, 2 times 7, and I'm getting those numbers, you could actually wait and just put those numbers up the side as you're doing it. And then it is literally just like that first one that we did. Yeah, that's fine. Yep. You absolutely can skip lines. You could do that this way too. You could do 0, 1, 2. Yeah, that's A-okay. And so then it sets up exactly like the first example we did. And you keep looking and you're like, this really is just kind of going right along with exactly what we've done here. When I get to number 4, it looks just like example number 4. So I've got a reference point. Now, I do want to say something, though, on number 5. Okay? The median annual family income in the United States was $40,000 in 2010. It had risen to $60,000 by 2013. Find the average annual rate of change in family income from 2010 to 2013. Okay, they give us a hint. They put 2010 as the X value in this first slot. What that's telling me here is that the money that goes with it is the Y value in that same slot. And when I come down below, it looks like the year is X, so I find the next year. That's going to be my next X. And then I find the next amount of money. That's going to be my next Y. And once I get there, X1, Y1, X2, Y2. Plug it into your slope formula and you're off and running. So I mean, at that point, you could say this is like number 3, it's like number 1, but really I just got to plug the numbers into the formula and I'm going to be done. Okay? But just remember, you're finding that rate of change when you get to the end. that last fraction that you get to has got to be something that's over 1. Got to be over 1. So if you get here and it's something less, make sure at the end that it's something 1. Number 6, just like example 3, pick you 2 points. Because again, x and y, they're all coordinates. Pick you any 2 pairs and use the slope formula. And you're in business. This is just letting us repeat all the things that we've been working on so far. And so once I've tried those out, the last one, oh, Hardy, you lied. You lied. We got another red slide, just like we had a red slide. Another red slide. And then finally, this one I want to chat about. Actually, this one I want to walk through with you, because this one is a little bit different. So the distance time graph shows 2 cars that are traveling at the same time. A going a little slow, B going kind of fast. Okay. Which car has the greater speed, and by how much? So here's how we can look and see that car B got further. So we know car B is going faster. But by how much, there's a couple of different ways we can calculate that. So if I look at this point right here, again, here's my x-axis, here's my y. That point is 6,480 for car B. And that point right there is 6,360 for car A. But for you to be able to find the speed, the rate, you have to have a second point. So let's follow her back down. Oop, there's another one. X, Y. Again, colors can come in handy. Follow it back. Oh, where am I going to tuck this in? 0, 0. So when I go to actually be able to tell you the actual speed, x1, y1, x2, y2.
There's 2 different problems.
y2 minus y1, just like it's always been on every other one. We just had to figure out the 2 points. x2 minus x1. Let's see here. 360 divided by 6 is 60.
Why do 360? Oh.
Again, labels 360, or in this case 60 kilometers per 1 hour. So car A was going 60. When I get to B, I do the exact same thing. So here's x1, y1, x2, y2. y2 minus y1 over x2 minus x1. Ooh, are we in for a shocker? Maybe. Maybe. Let's see. Woo, we're flying here. So now I can show B is definitely faster. by 36 kilometers per hour. So yeah, that's pretty significant.
Wait,
Nope, not waiting. No.
wait, no, I'm just speaking out loud.
Okay. So once I've done that, and again, it's just me taking the 4 points and doing slope. I'm not even going to do anything real rough. What does the point of intersection of the two lines mean? You're like, wait a minute, what? Where they cross,
Jesus Christ.
when they cross there, that is telling me, what is it telling me? What is that point where the two lines cross? Yeah, couldn't tell you. At that point, it's the same distance that they'd traveled. They hadn't been traveling the same amount of time. They definitely weren't going the same speed. But where it crosses, they both have gone the same distance at that point. So I can get some information from this that's going to help me out a bit as far as that goes. So on the other 7, you've got examples. Okay, we've got references for examples. Try those out. Answers are on Classroom. They're also up front too here in the binder. Let me switch binders around. And if you have got questions, I will be around in just a moment to take care of those.